In this short video, we are looking at the autocatalysis of the oxalic acid or the ethanedioic acid. This process is known to be catalyzed in an auto manner. So let's look at the equations here, and through the equations we can understand what is happening. So to start with, we have the oxalate or oxalic acid. So here we have CO4 minus 2. And the oxalate, it will be reduced to give the CO2. So this is one equation. And then we have the potassium permanganate, MnO4 minus, and this is, to start with, it will be reduced to Mn plus 3. And the Mn plus 3, it will be reduced to Mn plus 2. And the initial one here, this Mn is plus 7, because this we have a minus 1. Okay, now let's balance the three equations and see how the autocatalysis working. So in this equation here, to start with, we need to balance the number of carbons. So here we'll add 2. And what else we can do here? We have 2 electrons. In this equation, we have 4 oxygens here. That means we have to add 4 water molecules. And on the other side, we'll add the equivalent amount of protons. And then we need to balance the charges. So here we have 8 and minus 1, that is 7. And here we have plus 3. That means we have to add 4 electrons on this side. And then we have the Mn plus 3 being reduced to Mn plus 2. That means we have to add an electron on this side, 1 electron. Okay, so now we need to think of a way mathematically so that we basically cancel out the number of electrons from both sides. So here the number of electrons has to cancel out the rest of the electrons on these two equations, let's say 2 and 3. So here basically, if we multiply by 5 this equation, and let me change the color. If we multiply this equation by 5, so here we'll have 10 electrons. And here, if we multiply by 2, here we'll have 8 electrons. And here, if we multiply by 2, here we'll have 2 electrons. So this one, we will multiply it by 2. And this one will be multiplied by 2. Now, let's rewrite the equations so that we deal with fresh equations. So here we'll have 5 C2O4 minus 2. And this gives us 10 CO2 and 10 electrons. And then the next one, we said we'll multiply it by 2. So this will lead us to have 8 electrons plus 16 proton plus 2 MnO4 minus. This leads to 2 Mn3 plus and 8 water molecules. And finally, we have the 2 electrons and 2 Mn plus 3. And this will lead us to have also 2 Mn plus 2. Now, as you can see here, here the number of electrons, they'll cancel out each other. So here we have 10 electrons on this side. And let me just change the color again. So we have 10 electrons. And this will cancel out 8 and 2. And also we have the 2 Mn3 on the side, and we have the 2 Mn plus 3. They'll cancel out. And therefore, basically, you will have the final equation as we're looking at the equations in green. So we're talking about 5C2O4 minus 2 plus 16H plus 2 MnO4 minus, and this leads to 10 CO2 plus 8 H2O and 2 Mn plus 2. Okay, and just to verify your answer, here on the side, here you have 10 minus charges plus 16. So this is 6 minus 6 plus charges. And then here, the 6 you have to minus 2 minus. So this is plus 4 on the side. And here also you have 2 times plus 2, that is plus 4. So what's happening in these equations? As we can see, the Mn plus 3 is being this one here. To start with, the Mn plus 3 was produced, and then it was reduced. It was produced, and then it was reduced by means of the oxalic acid or the oxalate. It was reduced to Mn plus 2. The presence of the Mn plus 2, it was then oxidized again by the presence of the MnO4 minus, and this cycles keep going on and on until the concentration of the MnO4 depletes or go down until the process complete. I hope that was beneficial. Thank you for listening.